the Atom calibration framework. Now we are going to talk about the dataset playback, in particular reviewing depth annotations. As you probably know by now, you can iterate over all collections, and right now we are interested in the depth data, so I'm just going to take away the cameras, the RGB cameras, and turn on the depth labeling. Just perhaps I need this to be a little bit bigger, right? And also let's just keep the point cloud from LiDAR 1, otherwise this is a lot of information. So you can see here these cubes. Cubes are a symbol for depth data. We use spheres for LiDAR, and these cubes show the annotations that we have for the depth data. So you can see that the small cubes there represent the points that we believe are belonging to the pattern, and the big cubes are where the annotation says that there is the physical boundary of the pattern. So these cubes have a direct connection to the depth image that you see on the right. The depth image on the right has the small cubes represented as yellow, and the big cubes, the boundary ones, represented as pink. So whenever we can now go through many collections, of course, by pressing the right arrow or the left arrow, and whenever we come to the conclusion that some particular annotation was not good, as is the case, for example, here, although the other ones were also not very perfect, but let's say this one, we can actually correct this information. How do we do this? We are going to select the polygon that surrounds the pattern, and then the system is going to be able to extract the pattern. Okay, so I'm just going to do this here by clicking. In order for you to be able to click on an image display, you have to use a special RVs fork until it's integrated, until our pull request is accepted by RVs. So whenever we close the polygon here, it will relabel and come up with a new annotation for this collection and this sensor, this depth sensor. And I did this on purpose so that you can see here from the image, the depth image, that you have some pink detections there where the pattern is not present on the bottom. Although this is very hard to see on the depth image, but on the 3D data you can actually see, well, let me take away the LiDAR and also perhaps our robot. You can, well, the TFs for sure should go away. And you can see there that those points on the bottom are very far away, because these were points that were from the ground, far away, although they are close on XY, so on the image, they are far away in depth. So you have to be careful that your polygon does not include these points, otherwise you will have a bad annotation, and this will confuse the calibration. So we can just label this again. Let's do a new polygon. And it's better to have a little bit of the pattern eaten away than to actually have the situation that we have right now. So let me be a bit strict, and in this way we have here an annotation. Although the bottom part is not very accurate, it's better than what was before. So here we have a more or less good depth annotation, and this is the way to correct automatic depth labels. Thank you.